Hey guys, you're listening to Inside iOS Dev, a show about world iOS development, here with your host Andrew Rohn.
And Alex Bush.
Today we have a special guest, Basem Emara. He's going to be talking about clean architecture on iOS, his flavor of it, his interpretation of it. He is also the owner of iOSmentor.io, which gives courses on iOS architecture. Basem, can you actually introduce yourself some more?
Yeah, sure. Thanks for having me. So I've been doing software consulting, development, and architecture for about 12 years. And I've worked in different front end, back end, and even middleware for Fortune 500 companies and governments and startups. Right when Swift was released about 4 years ago, I fell in love with it and literally dropped everything and went all in. So I brought all my experiences from other technologies and languages to help pioneer the language and build enterprise apps.
So, what you what you reached out to us with was the clean architecture, right? And kind of your spin on it, if you will. And you wrote an article about it. So, could you tell us about that?
Yeah, I feel like I heard you say this before, but I also feel that the iOS community is in a bit of a crisis. So the iOS app architecture topic has been getting really popular lately. So I feel that MVC, and we all know MVC is great, but we're starting to realize it's actually a small piece of the bigger picture. So we always hear all these heated debates about frameworks and patterns, but they don't really touch on actual architecture. So, RX is just a framework, and even MVVM is just a presentation pattern. And these come and go, but architectures are timeless. So that's what I'm here to talk about is the clean architecture for iOS, which was coined by Uncle Bob, which some of your listeners are probably familiar with listening to your podcasts.
And then we both love Uncle Bob's work. So yeah, we mentioned.
Yeah, I read the book. It was a great book.
Yep.
Yeah. So just in case somebody hasn't heard about it, it was coined about 20 years ago, and it's independent of platforms and frameworks and databases and even UI. So it's flexible and testable. It's extremely feature-based centric. So it's pretty use case centric. So once you see the light, it's hard to turn away.
Right. So can you give us a brief kind of overview of I guess canonical by the book clean architecture, say an app with, I don't know, a Twitter app with two features, login and display tweets?
Yeah. Well,
just kind of high level of what it's going to be consistent of.
So there's a few components to the clean architecture, and usually when I was getting into this topic, I would get lost in all the terminology and things. So I want to kind of break it down for everybody. The clean architecture is really a full stack. That's what the architecture is, from UI to data access. So there's these components that start off in the view, and really it doesn't matter whether you're coming in from an app or a browser or even an endpoint or even Android. It doesn't matter. What matters is what happens beyond the view. And so when a user interaction occurs through the view, that's when the controller listens to that. And that's where the controller binds to the view to start calling the rest of the components. And when the controller takes the interaction, it actually talks to the next gateway for your library, which is the interactor. I'd like to also preface this before actually getting into the components, is that we all get confused with apps being really heavy with all our code. So really, I like to start off with the right frame of mind. apps should be extremely light. As a matter of fact, it shouldn't contain any business logic at all. The app should be seen as just a browser or a viewer, and it should only contain presentation or user interaction events. And so when we talk about app, really we could be talking about iOS or Android or a browser. So this is the first thing to accept when planning the architecture.
So you're thinking about the whole system holistically, then, right? In that scenario.
That's right. Actually, this architecture can be used in different platforms, and I actually worked with different teams that were in Android or web, and we're all using the same architecture, and there's a lot of synergy going on because we actually find one bug in one platform and we can find it in the other platforms.
Okay, can you unpack that more? This whole I guess holistic approach to it, where the browser or iOS app, right, as you said, doesn't have business logic, right? Where does it live then?
The app should actually have a framework. So the framework actually contains the rest of the business logic and the data access and the network. So when the controller listens for the events, it talks to the next component, which is called the interactor. And when I'm talking about these components, I'm actually talking them in order. So this is going to be a unidirectional cycle. So from the controller, it talks to the interactor, and the job of the interactor is just to juggle all the workers that are in your shared library. So in other words, the interactor asynchronously requests the models from your library. The interactor doesn't actually contain any business logic. Actually, your framework outside of the app has the business logic. This is where the data access, the network calls, and the authorization happens. And of course, with dependency injection happening there, so you can swap out the data access. But all this happens in the library outside of the app, without the app even knowing what the library is doing. When the interactor eventually gets the entities back, it will pass those to the presenter. The presenter is the next component in the architecture. This is where the entities are formatted into view models. These view models are really dumb, and they usually have all string properties. So even for dates or currencies, they're all in strings. And even localization happens here too. Once the presenter converts the entities to a view model, it passes that to the controller. It'll call a function on the controller. And then the controller will take that and bind it to the view. So this all happened in a one-directional flow.
Okay, let me let me see if I can kind of summarize this, Basem, and you tell me if this is a fair characterization or not. You can correct me. So I just want to see if I can summarize it quickly. So basically, you have your view layer, and your view layer could be iOS, Android, Windows Phone, if that is still a thing. And then you have your controller layer. So you go from your view layer, you let's say capture user input, you pass that into your controller layer. Then from your controller layer, you go to your interactor. And then from your interactor, then you communicate to your different workers. Now, the workers are within some framework that is outside of your app, your iOS or Android app. Is this correct so far?
Right, yeah.
Okay, and then so now in the separate framework that you've created, that's doing whatever the workers need to do, network call, database call, whatever, maybe mutating the models, and then something comes back to your app into that interactor. From the interactor, you, let's say it's Twitter, so let's say you hearted, you liked a post, the interactor comes back and says that was successful, and you tell the presenter, okay, from the interactor, it tells the presenter that was a like, and then in the presenter, you create some view model, maybe for the post where you update saying that the like happened. You send that view model to the view. finally your view updates. Is that kind of the whole flow, kind of as a summary?
Exactly. Yeah, that's right. That's right. One thing to note is every piece of communication that's happening between the boundaries is through protocols. So everything is implementing a protocol, not the concrete types. Also, when data is passed from one component to the other, it should be wrapped in a request or response model. That way, keeping these two rules in mind, it keeps everything decoupled.
And by the
testable.
component, you mean, say, the UI piece with the presenter to the business, logic part where interactor is, right? So that communication happens through the data transfer object. And then from the
that's right. Yeah.
I guess from the interactor to your workers, right? That piece also communicates through a data transfer object. Mm-hmm. Yeah, makes sense.
That's right. Yeah.
Okay, and so Basem, I think we understand the architecture now, and people can go onto your blog if they still don't to get some more info. I just want to move on, so let's just kind of set that aside now. So what does this give us? Like, why this seems kind of heavy? Why would we want to do all of this work?
Yeah, it feels verbose at first, but once you start maintaining it and actually working with it in extending it with features, you start to realize that you know exactly where everything happens. So if there's a problem with something in the view that's presenting the wrong currency, for example, then you go right to the presenter and you make those adjustments. If you have something that's wrong with the calculations, then you don't even have to touch your app. You have to go into your shared library, and that's where you make the adjustments there. And that keeps your app very light, so you can actually take this shared library and then use it in different apps, and then the same architecture works across different projects.
I'm really interested in the shared library, actually. So, what is this shared library? What is it written in, and how are you able to use it across different apps?
All it is actually a cross-platform framework that when you create a new project in Xcode, you go into the cross-platform tab, and then you actually create an empty project. Once you have an empty project, you can create Cocoa Touch frameworks or Watch framework or a TV framework. So you're adding these targets into your project, and then there's no app involved. You're just creating Swift files, and you're making it a member of iOS or TV or Watch and so forth. So you can make the same code work for different platforms.
So I'd imagine then in any code you write in there is probably you're only going to have access to Foundation and just plain Swift, and there's no UI kit or anything like that, right? No specific app library references to app like iOS libraries or frameworks.
Right. Yeah. You shouldn't reference any UI kit or anything. It's purely Foundation and any dependencies that you need, like Alamo Fire or whatever, like Realm, data access. So all of that it's just pure code, but there's no storyboards or view controllers in there.
And so is this reusable in something like an Android app?
Yep. So unfortunately, the Swift framework cannot be used in Android or other platforms, but because Swift and Kotlin are so similar, what we've done in teams is actually the teams work together to copy each other's code. So maybe we'll work on one area and the Android team will work in another area, and then we'll just swap and copy each other's code. And they're eerily the same. They're eerily pretty similar because of how similar Kotlin is. So yeah, we can find a bug in one and kill the other.
That's an interesting approach. Andrew and I we were talking about code shareability on one of the episodes, and the experience I had was with a JavaScript library where the business logic in it is shared between Android and iOS. that didn't work that well as you would expect. But another thing we thought of is this Kotlin. There's a development in Kotlin for compiling it down to LLVM executable, which can be natively launched on iOS, and then the same Kotlin code can be compiled to JVM code that can be natively launched on Android, right? So there is a potential there, maybe, but you say that so far you're kind of just copying the code, right?
Yeah, it's a lot of duplication, but I mean, we even examined should we write some of it in C++ and share it in both.
Mm-hmm.
And it just becomes overly complicated to the point where we lose a lot of the nice features from each of the languages. And it actually turns out not that bad. They each retain their own identities, but they're pretty similar. So as long as unit tests are in place, they seem to be the exact.
So Basem, Basem, so I feel like this is actually, to me, it seems like a pretty big offense, to be honest, of code duplication, and I don't. So let me see if I can phrase this. Basically, to me, I would think that ideally we could do something like either in C++, like you said or Alex said, where you can do it in Kotlin. You make your one executable that's shared, and then you compile that down and use it both in iOS and Android. But then you said also right now, we thought about it in C++, but you lose the niceties of, having the things that you get in Kotlin and Swift. So I'm wondering, is basically what you're saying, the benefits of having, let's say, a shared C++ code base is not as much as the benefits of having separate Kotlin and Swift code bases, but having tons of code duplication?
Yeah, unfortunately, there's to me, I haven't seen anything better. I don't think we have a solution. We're all striving for that one shared library to rule them all, but I think we're far from that still.
Basem, I have another question. Your controllers in this architecture in iOS, what do you consider your controller?
It's the UI view controller.
Okay, so I have a question, actually. That's what I thought. So there's a lot of people kind of stating these days that the view controller is not really a controller, which I actually agree with them. It's really part of the view layer. So I'm wondering, what was your decision to have the view controller basically take on the controller role?
Yeah, it's funny that they call it a view controller. It's actually both. So I actually looked at it as two different things. So the view part of it is the storyboards, and then the controller part of it is what interacts with the view and makes the call to the business logic.
So how is that? I'm kind of wondering now. What the presenter then? How does that play with the controller? What roles? How do they separate roles? And yeah, how do they play together, I guess?
The presenter will convert the entity to a view model, and then once it passes that to the controller is actually the only thing in the whole system that holds state, because it communicates with the view, so it needs to hold state, and that's important in a Swift world. So since that's the only place, it's going to take that view model from the presenter and simply just stick it to the view. It doesn't even know what's in there or care what's inside the view model itself. It just binds it to the view for the user to see.
Mm-hmm. And then, as you said, when the user input happens, right? Say a touch or something, then the controller communicates it up to interactors, right?
Right. Yeah, and then it follows that whole cycle again.
I see. So in that case, then presenter is basically reduced to doing the mapping of the models onto view models.
Yeah, that's right, and that's where the date formatters and currency formatters and localization happens.
So I have a question, actually. So your view controller, well, so your view control obviously has a UIKit dependency because it is an UIKit. But so the presenter, does that have a dependency on UIKit in this architecture?
No, it doesn't. Actually, it
Okay.
has a weak reference to the UI controller, but
Okay.
it doesn't know anything about UIKit.
So I have another question, and this is something me and Alex talked about before that we kind of found like quizzical. Your statement that apps should not contain business logic. I find that almost hard to believe, but it sounds like when you say that statement, what you mean is your main application target, not this shared library that you're talking about, but your like main application target that contains the view controllers and presenters, that should not contain business logic, but instead the business logic should be in the shared library. Is that what you mean? Did I interpret that correctly?
Yeah, yeah, exactly. And this framework is outside of the app and can be referenced from different apps.
Okay,
I see.
then
That
that
makes
makes
sense.
sense. Yeah, that makes a lot of sense to me. I was like, where would the business logic be otherwise? Okay, then that makes a lot of sense.
That is
Great.
actually an interesting definition of it because what I knew and kind of the way I understood it, and I guess other people I talked to also referred to it. Essentially, your app being that framework that you called the framework, right? Agnostic. That is agnostic of UI kit or app kit or anything concrete and specific of the platform you're running it on, and then the platform you're running it on is the library framework, right? Such as iOS, for example, that kind of plugs into your main app, if you will.
Yeah, this same shared library can be used in an iOS app, but it also can be used in a watch
Right,
OS app or tvOS.
right.
Yeah.
I guess that's just that's where the confusion came from. To me, I call the shared library the app because that's what's important with the business logic, right? And then the stuff around it, such as iOS or WatchKit or who cares what, is the pluggable libraries to display it, roughly speaking. But that makes sense, though. What you said.
Boss, I have another question. So this shared library, it sounds like earlier when you talked about it that it actually has, for example, if you make a network request, it sounded like you mentioned Alamo Fire. So it sounds like it's not actually completely independent of the iOS ecosystem, right? So I couldn't take this exact shared library, compile it down, and put it in my Android app. Let's put aside the fact that we can't compile down Swift, but let's say tomorrow they came out with this development, we can now compile down Swift and share it with Android. Doesn't that make it kind of violate the clean architecture principle that I'm using Alamo Fire, like these iOS specific things in that shared library?
That's where you lose the niceties of the languages. And we're always going to need dependencies. Every software has depend. If you can get away with dependencies, you're Superman. So because we have to live with dependencies, it makes our lives easier. We just have to. To make it in a way that we leverage dependency injection, so that way we can swap dependencies out, makes our lives a little bit simpler. But back to your question is, this makes it not used in different platforms eventually if there's some cross-platform with Android, for example. But that would, if unless we can find, if we stick with just like C++ dependencies or whatever this magical cross-platform language would be, copying code from one shared library to Kotlin, for example, that's actually, as long as we wrap our dependencies, most of the code would be exactly the same.
Right. It's hypothetically, if you abstract your networking code out with a protocol, you kind of get that, right? Essentially, your core framework, your library that's shared, is talking to that protocol, and then on Android, let's say, something else implements that protocol to do the actual Android specific networking, and same on iOS.
I guess the point I'm trying to make here in terms of my questioning is the architecture you've presented is based off the clean architecture, yet the the networking and the data access and your architecture that you propose is not following the clean architecture principles by putting the networking and that persistence information as external dependencies to these libraries, which is fine. I'm just wondering, like, why do you draw the line there to say, like, well, I know that's not clean architecture per se, but we have to have these dependencies, and the world's not perfect, and so we're just going to allow them to be in there. Like, is it just more that you made that decision because it's convenient and you think it's worth the cost of having that dependency?
Well, I do think that it still follows clean architecture because of the dependency and inversion principle still playing a role with the dependencies. So actually, the dependencies are injected into these workers with protocols. So what's happening behind those protocols can be all kind of different dependencies, or even a dependency you wrote yourself. But as long as everything is communicating with each other with protocols, I feel that it's still within the lines of clean architecture.
Yeah, it makes sense.
I understand. Okay, I get it.
There was one last piece of the puzzle, which was the router. And I've seen in some different implementations of clean architecture, this gets really complicated. And so making the router very native, just presenting and pushing, makes everything much more sweeter. So you don't have to have much complicated code to move between views. So as long as you keep that router separate and wrapped in a protocol, the view controller will call the router to switch views, but not really know what's going on underneath it. So I just wanted to, in case there's room for that, I just wanted to throw that out there.
Sure.
Okay. So I just also wanted to mention that it's most of this is pure Swift, and you don't really need many third-party dependencies. So even reactiveness and RX, it fits, but we don't have to give the whole app away to RX Swift, for example. And also, there's a lot of different implementations like Viper out there, but I feel like Viper puts the presenter in the center of the universe. So it's not a massive controller anymore. It's just a massive presenter.
Right, yeah.
Yeah, I've heard that.
I feel that, separating everything in a unidirectional flow is kind of the game changer.
Okay, Basem, thanks. I feel like we've got an understanding of your architecture, how you describe it. I think, to be fair, though, people should probably check out your information online and really dig into it and learn the nitty gritty, because we can only cover so much in here. So can you tell us where people can find out more about you?
Yep, you can go to iosmentor.io, and from there, I've been doing a lot of on-site mentorship programs for enterprises and development teams around the world, but now I'm working on a video course to help intermediate and senior developers build scalable apps for their own projects and companies. It's in the making, but I put together a curriculum and webinar that you can see on the site there.
iosmentor.io, guys. Check it out. Okay, I guess that's everything, guys. Thanks so much for listening. Basem, thank you for joining us. This is very interesting. Check out iosmentor.io. Find us at InsideIOSDev on Twitter. Thanks, guys. Take care.
Bye.